Hello. Hello. How is the setting, please? Hello. How is the setting? Please, let's hear from you. How is the setting? Good afternoon. How is the setting? Can you see me? Is the setting inverted? Let's hear from you, please. Good afternoon. Is it inverted? Can you see the board? Is it okay? Please talk. Good afternoon. Good afternoon. How is the setting? Can you see me? It is okay, but blurry. Okay, with time. How is the setting? Can you see the board? Can you see the board? It is not inverted. It is okay. It's okay. Okay, thank you. It's okay. It is blurry. That blurriness will be controlled later. It is blurry. It is blurry. All right. It's okay. How is the positioning? How is the positioning? Is it okay? Is it okay? Very clear now. Okay, thank you very much. Shall we start? Shall we start? Shall we start? Yes, okay. All right, thank you very much. We managed to do this because of the challenges we've been facing as a result of the network and some other logistic problems. So what is important is your commitment, dedication, and eagerness to learn. Okay. So don't let us consider the challenges, because while considering the challenges, we will not go anywhere. Can you hear me? Can you hear me? Can you hear me? Please, if you can hear me, let me hear you. Let me. Okay, you can hear me. Very good. So now let's actually start our review today with where we stopped yesterday. Please, if you are not here today, you will miss a lot. To be honest to you, whoever is not here today will miss a lot. So we're going to start with another trick of solving problems in integration. Yesterday, we talked about certain tricks that can be used to solve problems in integration. These tricks are very, very effective and efficient because they don't waste time. Are we getting me now? They don't waste time. Once you are able to know this trick, you will not have any problem. Instead of you spending hours on certain questions, with the use of the trick, you will get the problem solved within a few seconds. So let's look at this one. Let's look at, suppose we are asked to evaluate this word, sine x dx. You'll be wondering, we did something like this yesterday, but why again? Why are you talking about this again, sir? No. The method we used yesterday was different from the one we are going to use today. Yesterday, I told you that if you have a function that has a function of multiplication like this, product function, there are two functions here. We have a algebraic function and we have trigonometric functions. Okay? Now, basically, this function, this particular problem could be solved using what? Using integration by parts. But if you are to use integration by parts in the examination hall for this type of question, you will waste your time. Okay? I remember I told you that for a question, you must not spend up to 1 minute. The moment you spend up to 1 minute on a question, it will affect you and you will not be able to finish the exam. Okay. Now, what are we going to do here? Instead of us using integration by parts method here, there's a method we call D-high method. What do I call it? I call it D-high method. D-high method. What is the meaning of D-high method? D here stands for differentiation, while high stands for integration. Are we following? Hello, are we following, please? Are we following? Let me hear from you. Are we following? Should I continue, please? Are we? Oh, beautiful. Now, this DI method means you are going to, it's a tabular method. A tabular method. The first column is differentiation for D, while the second column is integration. Okay? Now, how do we go about this DI method? You can only use, because it has a limitation. But if you know it, oh, it is okay. Its limitation is just that from the two functions, one could give us 0 quickly when differentiating. Again, from the two functions, we have two functions here. We have x squared sin x dx. Now, one of these functions must give us 0 fast when you differentiate it. So if you have a combination of two functions of which one can easily give 0 when differentiating, then this DI method is the most ideal method to use when you have this kind of problems. Okay, now in this case, now we pick x squared as our D. X squared will come under the D what? The D version. Okay, why? That means that you will have to what? Integrate the second one. Okay, now you integrate the second one directly. When x in integration, when you integrate sin x, you have minus cos x. That is that. Now you start. You know, integrated sin x, get this. We write this x squared. No, now when you differentiate x squared, the first time you have what? 2x. Now you integrate your minus cos x again. Now, by the time you integrate your minus, you know, when you integrate cos x, integration, it gives you sin x. With this minus, you have minus sin x. Beautiful, beautiful. Now, again, you differentiate your 2x. You get what? You get 2. When you differentiate 2x, you have 2. Integrate minus sin x again. Don't forget, when you integrate sin x, you get cos x. So that's what? Sorry, you get minus cos. Sorry, that's minus cos x. Okay, good. You are integrating. Remember, it has minus here. Then sin x, when you integrate it, it gives you minus cos x. Fine. Now, differentiate 2 here now. You get 0. Since you have gotten 0, you don't need anything to do with this second one again. The moment you have arrived at 0, it means that that problem has been terminated. Please, are we following? Are we following? Are we following? Please, I want to hear from you. Are we following? Let me hear yes or no, please. Are we following? Hello? Oh, beautiful, beautiful. Now, we have gotten 0. Since we have gotten 0, we stop the operation. You don't continue again. Now, you now multiply across. But before you multiply across, you alternate the signs. You ascribe them signs. The first element here, you give it plus. The second element, you give it minus. While the third element, you give it plus. You alternate. Now multiply across. Multiply across will give us what? Let's check. Let's check. Now plus minus plus. Okay. Plus x squared minus cos x. That's it. That's multiplying across. That's x squared multiplied by minus cos x. Beautiful. Then minus 2x multiplied by minus sin x. Minus 2x multiplied by minus sin x. Beautiful. Then the last one plus 2 times, this one is already plus. Minus times minus is plus. Okay. So this one is plus. So you have 2, that is plus 2 multiplied by cos x. Okay. Now let's write everything out. We have minus x squared cos x. You know, minus times minus is plus 2x sin x. Then the last one here is what? Plus 2 cos x. Plus 2 cos x. Okay? Are we following? So, are we following? Yeah, oh, beautiful. This is the answer. This is the answer. It's as simple as that. It's as simple as that. I can assure you, it's as simple as that. So the last thing is just to add plus C. You know, it's a constant of integration. You have to add plus C because this is not a definite integration. So with this, you have solved this problem. It's as simple as that. Yes, I can assure you, anytime you have a function in which one of the function is going to give you 0 fast while integrating, you use this DI method. Let me look at if we can have another example where we can use DI method. Let me see. No, for now. Okay, as we go on later, we look at more examples on this aspect, then we will drop, we solve it. But this is basically the way it is going to be solved. Don't forget, between the two functions, one of them must quickly give you 0 when you differentiate it. So, and since x squared will give us 0 when we take the process of differentiation, yes, God of mercy. God of mercy. God of mercy. Have mercy on us. Have mercy on us. The network is bad. God will have mercy. Can we continue? Can we continue? Can we continue? Hello? Shall we continue? Can you hear me? Hello? Can you hear me? Can you hear me? Hello? Hello? Please say something if you can hear me. So you can't hear me. Hello, can you hear me? This is terrible. Hello? 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 Hello, can you hear me? Can you hear me? Please let me hear from you. Can you hear me now? Can you hear me now? This network is terribly bad. Oh, God of mercy. Have mercy on us. Have mercy on us. Hello? Hello, can you hear me? Hello, can you? Hello, can you hear me? Can you hear me now? Hello? Can you hear me? Hello, can you hear me? Oh, terrible. Hello, can you hear me? It's quite unfortunate. It's quite unfortunate. Can you hear me? Not at all.